The other property we need to talk about is the distributive property. Its full name is the distributive property of multiplication over addition. That's quite a mouthful. We'll see why it's called that in just a moment. Most people just call this the distributive property or distribution. But when they say that, they mean this property, the distributive property of multiplication over addition. The distributive property looks like this. If I want to multiply the sum of 2 and 5 by 3, I can write it this way. This is like saying 3 times whatever 2 plus 5 is. By order of operations, I know I have to do this sum first. So this would really be 3 times 7. And of course, 3 times 7 is 21. The distributive property says that I don't have to do it in this order. I can think of this as 3 times 2 and 3 times 5. In other words, this is 3 times 2 and 5. So this is 3 times 2 and 3 times 5. Order of operations here tells me I need to do multiplication before addition. So here I get 6 plus 15, and 6 plus 15 is also 21. In a more general sense, I can write this as a number times a sum of two numbers can be written as the sum of the product of the first number and the second number with the product of the first number and the last number. That's a lot of words. When I teach this class face-to-face, I tend to use this notation. Let me emphasize that this is times here, and then to get from this notation, to get from this step to the other way to write this, I would say this is like saying 3 times 2 plus 3 times 5. This is like saying A times B plus A times C. When we're just working with numbers, it doesn't matter which way you do it. And in fact, technically, since we have order of operations, we really should do what's inside the parentheses first. But sometimes we don't have that option. Sometimes we have problems that have variables in them. So for example, instead of 3 times 2 plus 5, this said 3 times x plus 5. I would not have the option to add the 5 and the x together first because I don't know what x is. But I can rewrite this as 3 times x plus 3 times 5. This becomes 3x plus 15 because I can simplify the 3 times 5. And that's why it's called the distributive property of multiplication over addition. Here's the multiplication, and I have to multiply that 3 over this sum, over this addition. Multiplication over addition. I'm distributing the 3 over this plus, x plus 5. Let's summarize a little bit before we go on. So far, we've talked about the commutative properties of addition and multiplication, the associative properties of addition and multiplication, and the distributive property of multiplication over addition. In general, these properties look like this. The commutative property of addition says I can take a number A and add B to that, or I can take B and add A to that. A and B have to be the same two numbers, but they can be written in either order. The commutative property of multiplication says that I can take two numbers, A and B, and multiply them, either A times B or B times A. Again, the same numbers have to be used, but they can be in either order. The associative property of addition says that I can associate A and B in addition before I add C, or I can associate B and C in addition before I add that to A. The associative property of multiplication says I can associate A and B in multiplication before I multiply the result by C, or I can multiply B and C first and then multiply that result by A. The distributive property of multiplication over addition says that I can take a number and multiply it by the sum of two numbers by doing the sum first, or I can multiply that number by each number separately and then add the two together. Those are our 5 properties, although really there are only 3. One is the commutative property, but it works on both addition and multiplication. One is the associative property, but it also works on addition and multiplication. And the third one is the distributive property of multiplication over addition. Most people just call this distribution or the distributive property. When we talk about the distributive property of multiplication over addition, we're really talking about the distributive property of multiplication over addition or subtraction. In other words, since subtraction is really addition of the opposite, I can write this as A times B plus this plus right here is now the same as that plus right there. And this plus right there is the same as this one. But notice that when I multiply the A times the B, I get AB, as I did in the line above. But when I multiply the A times the second term, I have to multiply A times negative C. Well, A times negative C is going to be a positive times a negative, which gives me a negative AC. So if I just took out this middle step now, and perhaps removed some of these notations, you can see how the distributive property of multiplication over addition also works for subtraction. And that's because addition and subtraction are cousins. Subtraction is just addition of the opposite. So the same thing's going to be true here. If A plus B is equal to B plus A, then do you think it's true that A minus B is equal to B minus A? Well, this is somewhere we have to be very careful. Here's an example. Is 3 minus 7 equal to 7 minus 3? It's not. 3 minus 7 is negative 4. 7 minus 3 is positive 4. These are not equal. So we can't just turn them around the way we can with the sum, with the plus sign. What we can do is we can say that A minus B is the same as A plus the opposite of B. Now I've got a plus sign in there. I can rewrite this as the opposite of B plus A. Let's try that with our example. 7 minus 3 means 7 plus the opposite of 3. So I should be able to write that as negative 3 plus 7. Well, let's give it a try. 7 plus negative 3, or 7 minus 3, is 4. And negative 3 plus 7 is also 4. So it works. In other words, the commutative property of addition works on subtraction, but you have to remember to change the subtraction to addition of the opposite before you begin. You can't just reverse the numbers and leave the minus sign in between them. What about the associative property of addition? Same thing. If one of these plus signs is a minus instead, then before I use the associative property of addition, I have to change this minus into a plus the opposite of b. Now I can use my associative property of addition. This becomes a, my first number, plus parentheses, the second number, which is negative b, added to c. If it's this sign that's a minus, then that's the one that needs to get changed to plus the opposite. And then I can proceed a plus parentheses b plus negative c. Both negative? Well, then I have to change them both to addition of the opposite. And then I can rewrite my problem as a plus negative b plus negative c. Both the commutative property and the associative property of addition work when you subtract instead, but you must first change the subtraction to addition of the opposite. Okay, what about division? Can I just say a divided by b is equal to b divided by a? I hope you can see that that's clearly not true. For example, is 6 divided by 2 equal to 2 divided by 6? No, this is 3, but 2 divided up into 6 equal parts is actually a third. These are not the same, so I'm not going to get away with this rule. Not this way, but there is something I can do like I did with addition and subtraction to make sure that I can use it. Just like subtraction is the cousin to addition, division is the cousin to multiplication. A divided by b is the same as a times 1 over b. Now I have a multiplication problem, so I can rewrite this as 1 over b times a. The associative property works the same way. A times b divided by c is really a times b times 1 over c. So I can rewrite that as a times b times 1 over c. Before I try to apply the commutative or the associative property of multiplication, I need to rewrite the problem so that the division is a multiplication of the reciprocal or a multiplication of the inverse. All right, here's a summary screen of all the properties that we've learned in this section, including the variations on those properties for subtraction instead of addition and division instead of multiplication. It's a little messy and it's a little crowded, but it's all on one screen, and I'm hoping that you can take from this any notes that you might need to use on an exam. Remember that your first and third exams will be online and you can use any resources that you want. Your own notes, all of them, the internet, your textbook, and anything else that you can find. Your midterm exam and your final exam, however, are in-class, on paper, 2-hour exams. You won't have access to all of those resources, but you may use a 3x5-inch index card with any notes that you want to prepare in advance, both sides. Everyone's going to have different things that they need help remembering. Instead of giving you a sheet of formulas that I think you need, a 3x5 index card gives you the opportunity to write down what you think you're going to need help remembering on those exams. This is just one example of some of the kinds of things that you might want to write down. It's entirely up to you whether you write these notes or other things.